x square minus eta y dz along the path. One question, y equal to x, and second question, y equal to x square. So you know the idea about this one, because the path y equal to x. So 0 to 1 plus I. So 0 is here, origin, and 1 plus eta is here. So we need to integrate this one from 0 to 1 plus I along the path y equal to x. It means one path is y equal to x. Y equal to x means a line, and second path is be y equal to x square. So for the first one, we want to evaluate 0 to 1 plus I. So there are two ways to reach at this point 1 plus I from origin. One point, we can move on x-axis at up to the point A. Then from A, we may reach at point B. There is another option to reach at point B. Is first we are going to move on y-axis up to the point B, and then from B we are moving towards P. So we can reach at this point P. So there, and in fact, these are two in front of you, but there are so many paths to reach at point P from the point O. So what we discuss in this solution, that y equal to x, it means we have been taken the parametric equation of the curve y equal to x equal to t. So from here, dz is equal to dx plus I dy, and dx is dt, dy is dt, so 1 plus eta dt. In this case, the problem may be reduced like this one. It was our problem. This was, so t square minus it, because you may see the problem is x square minus eta y. So x square means t square minus it, and dt is 1 plus I dt. Now, when x and y varies taken as t, so your the integration was from 0 to 1 plus I. 1 plus I means what? Here z equals 0, and here z equal to 1 plus I. So z equal to 1 plus I means x is 1 and y is 1. And at the lower point, z equal to x plus iy, it means x is 0, y is 0. So if we can find the limit of t either from x or from y. At lower limit, x is 0, then t is 0. And at the upper limit, x is 1, that's why t is 1. Same thing can be obtained from y also. So limit of t is from 0 to 1 dt. Now it's very simple integration. Now we may integrate it, and the result is coming like this. Now we are going to integrate same curve, same integration with respect to the parabola y equal to x square. Y equal to x square means we have been assumed x equal to t. So y will come t square. So dz means dx plus I dy. So dx means dt and dy is 2t dt. So in this way we got the value of dz like this one. Now again we may find the limit of t from x. So limit will come t as 1 0 to 1. So this one, and then 1 plus t dt, and when you will integrate it, then result will come this one. So you may see, in one case we are getting 5 by 6 minus 1 by 6i, but in other case we are getting like this one. So when we choose two different paths to integrate x square minus iy dz from 0 to 1 plus I, then the value of integration is coming different. There is another way also. It means same thing you can integrate. It means 0 to 1 plus I as O to A, then A to P. You need to do it. I'm not going to do it. It may be asked, or O to B, then B to P. So accordingly, you may find the value of the integration. It's not problem. Next question, you may note down. Question number 2. Please be ready. Just I will ask to someone. Over this C, the curve C, e to the power sin z square. dz where C is unit circle, mod z is equal to 1. Yes. Please raise your hand. Who will give the answer of this question? Yes, I am watching. Yes, please raise your hand. Faraz. Faraz Samim. No one is going to raise your hand. Faraz Samim. No. Masra Begum.
Yes, sir.
Yes, what the answer of this question?
Sir, 0.
0. Why?
Sir, because Z will be a closed region. Z is representing a
Z,
closed region.
Z is a closed region?
So mod Z is equal to 1. It is given. Then it will be a circle.
Yes, that's okay. It is a closed region.
Yes, sir. Then by Cauchy's theorem, we can say that it would be 0.
So what is the Cauchy's theorem?
Sir, if Fz is analytic in R, then integration of...
So what is Fz?
Sir, Fz is e to the power sin Z squared.
It is sin z square. And it was sin z square is analytic. Yes, please.
Sir, e to the power Z is analytic, but I am not sure about e to the power sin Z square.
Then how we are going to say it is 0?
Sir, I think that I thought it would be...
So it means you may, can you check it whether it is analytic or not?
Yes, sir, I am checking it.
Okay. So you may check. Anyway, to handle the integration question, there are few points you may keep in your mind. First, I'm going to write it as point A, or first point. Draw the region. Okay? Everybody please be careful. Draw the region. What is the region here? See the circle with center origin and radius 1. So what we can do? We can draw the circle of radius 1. It means like this one. Center at origin and radius is 1. Now the question just started, so please be careful. Try to understand few questions, then you can answer the other questions immediately. So these are few points, few steps. What we did? First, we draw the region. So region means C. See a center at see the circle center at origin and radius 1. Second point. Second point, find the points find the points where fj is not analytic. Okay, in this case e to the power sin z square, fz is e power sin z square. And you may check it, this fz here, the function fz is, yes Masura, have you got it? Masura?
Yes, sir. Sir, I was not doing, sir. I was listening to what you were saying, sir.
Okay. Okay, by default, you know, sin z is anything or not?
Yes, sir.
So e to the power sin z square, you may go and check it. Exponential is also analytic. E to the power z square is analytic. So you may find out e to the power sin z square is analytic for all z. For all z. Okay? So it means there is no points at which function is not analytic. Suppose we are getting there is a point at which a function is not analytic, as it is mentioned that find the points where function fz is not analytic. Now then next point, check whether the points are inside capital C or not. Okay, if not, then as per Cosine integral theorem, integration will come 0. Will be 0. These are the complete steps to find the value of the integration. So in this case, first point, if our z square is analytic, if we have been draw the curve, then fz is analytic within and on C. So no need to find the points. It means integration e to the power z square dz as per the Cosine integral theorem, the result will come 0. So thus you may mention that this integration is 0. Thus integration this is equal to 0. We have been evaluated the curve. It's okay. Next question. E to the power z divided by z square plus 9. Who will tell me? And where c is mark z equal to 2. Next, Nitin. Nitin Sukla.
Yes, sir.
Yes, please give me the answer of this question.
सर सॉल्व कर रहा हूँ 1 मिनट सर.
सॉल्व कर रहे हो, ठीक है, बताओ. But you will do first. Yes, please. What you will do first?
Draw the reason.
Draw the region. So region is like this one. Then second point. Yes, please. Find the points where fz is not analytic. So how we can find the points where function fz is not analytic? The function is this one. Find the points where fz is not analytic, but the function is this one. So in order to find the points where the function is not analytic, generally you may equate the denominator to 0, because exponential, you all know that e power z is always analytic and polynomial is also analytic. So numerator and denominator both are analytic everywhere. But at that point where this denominator is going to become 0, this whole will tends to infinite. So at that point this function will not analytic. So just put z denominator to 0, and then by equating them you can find the value of z. Z will come plus minus 3 iota. Am I right? So it means this function is analytic everywhere except, yes please, except,
जिस थ्योरम में अप्लाई होगा सर आंसर 0 हो जाएगा.
नहीं अभी तो बताओ इसमें क्या, except this function analytic everywhere except
plus minus 3 iota.
plus minus 3 i. Thus function fz equal to this is analytic everywhere except z equal to plus minus 3i. Then what was the third point? Check whether the points are inside C or not. How to check? It means we will take the distance. In this case, we may take the distance of this point from the origin. From the origin of the C center. That is center of the circle. If the distance of a point from the center of the circle is greater than the radius of the circle. Again I am repeating. If the distance of the, because we need to check about these points 3i and minus 3i. These points are inside C or not. So we will find the distance of this point from the center of the circle. If this distance is coming greater than radius, then it will be outside of the circle. And if it is less than the radius, then it will be inside the circle. So check whether the points are inside C or not. So in this case, we may find the distance z equal to, we may say like z1. One point is z1, 3i, and second point z2 minus 3i. So in order to find the distance d1, distance d1. d1 means the distance is equal to modulus of z1 minus z2, z2 in the sense origin. So this implies d1 is equal to 3i. So in place of z1 we may use 3 iota 0. This implies it will come 3, which is greater than 2. What is 2? 2 means radius of the circle. Similarly, we may get the distance d2. This one, it means d2 is equal to minus 3i. It means d2 will also come 3 is greater than radius. Thus, both points lie outside C. Hence Fz is analytic everywhere. Hence Fz of this is analytic everywhere inside C. Thus, integration Fz dz over C is 0. I hope the procedure of the integration is now clear. Thus, integration of this one is equal to 0. Yes, Nitin, is it okay?
Yes, sir.
So now, anyone have any question, any doubts? You may ask me, please. Concept is clear. How to find the value of the integration? First, draw the curve. Second, find the points where the function is not analytic. And after that, we may check whether the points lie inside or outside the C. If outside C, it means Fz is going to become analytic everywhere inside C. So as per Cosine integral theorem, thus by Cosine integral theorem, this integration will become 0. It's okay. So I hope you had the idea. You got idea how to find the value of complex integration. Few more questions I'm trying to give here. Here, in place of this one, tangent, where mod z equal to 1. We'll give the answer of this question. If you clear the concept, then you may raise your hand now, please. Mukesh? Mukesh?
Yes, sir.
What answer this question?
I'm trying, sir.
You are trying, it means you are not listening carefully.
No, sir, I'm
Yes,
listening,
sir.
sir, carefully.
तो अगर सुनने थे मुकेश तो क्या प्रॉब्लम इसमें? Just you need to draw the curve C circle centered origin. That is one. Now think about tangent. Tangent is analytic or not?
Analytic, sir.
Analytic everywhere. Yes, please. Mukesh, tangent is analytic everywhere
Except pi by 2, sir.
except pi by 2 only. Tangent. Tangent means what? Sin
pi by
z
2, sir.
by
Yes, sir.
sin z divided by cos z. It means this is anything everywhere except at those points where cos z is equal to 0. Cos z equal to 0 means what? Z equal to, yes please, Z equal to
Odd multiple of pi by 2, sir.
pi by 2. It means we can say
2n plus 1.
plus
2n
minus
plus
pi by 2 comma pi by 3 pi by 2, am I right? Comma 5
plus
pi
minus
by
pi by 2.
2 and so on.
Yes, sir.
Okay, so it means this
Yes, sir.
function is identical everywhere except these points. Now we need to check whether these points lie inside this C or not.
Yes,
So
sir.
pi by 2, from pi by 2, pi, it means you know the value of this pi. Pi is, what the value of pi by 2?
90, sir. 90 degree.
In case of angle 90 degree, but in case of distance,
One 1.52.
1.52. So 1.52, it means the distance of this point from origin is 1.52, which is greater than 1. Hence, the value of this integration is 0. When 0? When C is this one. But at the same time, if I am going to change this question, what was the value of pi by 2? It means it was came like your
1.57.
1.57. So I'm going to put it as 2. Now, yes, please tell me whether this value, now this value will become 0?
No, sir.
No. So in this case, this will not come 0. Please be careful. This is not going to come 0 because there is one point, not only one point, 2 points plus minus pi by 2 inside C where the function is not identical. So it means we can't use Cosine integral theorem and then the result will not come 0. So be careful, please. First, you need to check whether the function is identical. First, you need to draw the curve. Then you need to check at which point function is not identical. And then you must confirm that those points are not lying inside C. If lying inside C, then we can't use Cosine integral theorem. If not lying inside C, then we can use the Cosine integral theorem and the result will come 0. Is it okay? So this is the concept of Cosine integral theorem. We may go with some more problems. I think number of problems is more than enough. Anyway, a few more questions you can write down. One divided by z power 3 minus 1 dz, where C is where C is a triangle with vertices at 0 plus minus 1 by 4 plus I by 2. One more question. Please note down these questions. 3z plus 5 z square plus 2z. Let's see is mod z is equal to 1. You have noted the questions?
Yes, sir.
Okay. So now next theorem is Cosine integral formula. Please be clear. Whatever we have been studying, that was Cosine integral theorem. When I am asking in the question, then students are always confused in Cosine integral theorem and Cosine integral formula. So, whatever we have been studying right now, these are the Cosine integral theorem. Theorem. Now, we need to study the Cosine integral formula. And before going to study the cosine integral formula, there's some application of cosine integral theorem. Application of cosine integral theorem. Anyway, I will come on that one a bit further. Anyway, so we can write that one as extension of cosine integral extension of cosine integral theorem for multiply connected domain. Let function fj is analytic in a closed contour capital C except at points z1 z2 z3 and so on. z1 z2 z3 z4 and so on. we may use at ZN. Okay. It means function is analytic everywhere except these points, as I have shown in this picture. This Z1, Z2, Z3, Z4. Okay, so if the function is analytic everywhere except the points Z1, Z2, Z3, Z4, so on, then Sachin Kumar. Sachin Kumar. Saksham Shukla.
Yes, sir.
Yes, Saksham. Can we use Cauchy integral theorem in this case? If function is
Let,
analytic everywhere except these points, so can we use Cauchy integral theorem?
no, sir.
No. Why? The
Sir,
statement of
because
Cauchy integral theorem?
yes, sir.
But the statement of Cauchy integral theorem?
Sir, if the function fz is analytic in a domain C, and then integral fz is dz equal to 0.
It means fz should be analytic at every point inside C.
Yes, sir.
Am I right?
Yes,
Then
sir.
we can use Cauchy integral theorem. But
Yes.
in this case, fz is analytic in a closed contour C except these points. It means at these points, function fz is not analytic. So it means these are creating problem. So if anyway we can remove these points, if we can remove these points, then I think function will become analytic and we can use Cauchy integral theorem. Am I right or not? Yes, please. If we can remove these points anyway, then I think our problem will be solved. So what we are going to do, we are going to put a hole in the sense in such a way that this point can be removed from the curse, that region. So what we can do, let us construct a circle. I'm just saying one thing. Let us construct a circle C1, C2, C3, so on. Circle capital C1, I'm making only one things and you can understand the whole. So this is C1. Similarly, if Z2 is this, Z3 is this, Z4 is this. So we may construct a circle, C2, C3, C4, so on. So let us construct circles C1, C2, C3 and so on, Cn at center Z1, Z2, Z3, so on, Zn respectively. Am I right? Thus, function fz is analytic. Thus, function fz is analytic in a region bounded by C, C1, C1, C2, C1, Cn. Am I right or not? So if we are going to do like this one, then in the region which is bounded by this curve C, C1, C2, C3, C4, in that region, it means if you are here, then I can show this one as like this one. In this region, this one. It means which is the color in this region, fz is analytic. So if it is analytic, then by Cosine integral theorem, therefore by Cosine integral theorem, integration C means what? Yes, C means this is fz dz is equal to 0. What do you mean by this fc here? So I'm breaking it. This equal to 0 means what? I think it is not required, otherwise to make create confusion. This plus this equal to 0. So plus, please see the picture. Whole this curve is C. And now C1, C2, C3. So think about the orientation. Suppose its orientation is anti-clockwise. So we are moving through anti-clockwise, then we are going to enter in this C1. So when you are going to move into C1, then you will move throughout the clockwise direction. Then you can come outside. So clockwise direction and first one is anti-clockwise direction. So the integration of this C1 will become minus. But before that one, suppose this is AB. So we may use plus integration here AB fz dz plus integration in place of AB, see the picture, AB then in reverse direction. In reverse direction, initially I am writing A dash B dash. A dash B dash, where A dash B dash is minus AB. So minus integration. Here C means C1. And then plus so on. I'm not going to write R. Equal to 0. This implies we may mention that AB is equal to this AB, path is equal to minus A dash B dash. So we may write this whole as this one, and here it becomes minus AB, and this whole equal to 0. So the joining path is going to be cancelled out to each other. This to this one is going to be cancelled out. So minus this, then minus, I hope you all know this one, minus C2, then minus, so on, and then minus Cn equal to 0. So what this implies that C is equal to C1 plus C2 plus C3 plus so on plus Cn. It means if function is analytic inside C except Z1, Z2, Z3, so on, so we may remove them, and in that case value of the integration over C will be equal to the value of the integration over C1 plus C2 plus C3 plus C4, like this one. Is it clear?
Yes, sir.
Okay, so any question? No. So we'll solve some problem based on this one in the next class, because time is not going to permit me. Wait a minute, I will take the attendance, then you may leave the class, please. Now I may leave the class.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome.
Thank you, sir.
Yes, sir.